Continuing on page 2 of the section of notes that we're in for 7.5, what if you get pretty further on in the assignment and you run into something like this, where they ask you to factor completely, and it's 12x squared times the parentheses quantity x minus 1 minus 4x times the quantity in parentheses x minus 1 minus 5 times quantity parentheses x minus 1. That looks really different at first glance from what we have been doing. So let's analyze this just a little bit more. Come over to the side with me here. And what if it had looked like this? 12x squared y minus 4xy minus 5y. And remember, our first rule of strategy would be to ask for, is there a GCF? Very good. So is there a GCF? Yes, it has a y in common. So you would pull out the GCF of y, leaving behind 12x squared minus 4x minus 5. Okay, good enough. What if it had looked like this, where it was 12x squared times something in parentheses, minus 4x times something in parentheses, minus 5 times something in parentheses. And I told you that inside those three parentheses was an exactly matching thing. Whatever that is, I'm just telling you it's the same in all three spots. Then, being the good factoring, boringly good factoring people that we are, we'd still say, hey, well, that's what they all have in common. And we'd pull out the GCF of whatever that was, that same thing. We'd pull it out no matter what was in parentheses because it was the same in all three terms. And it would leave behind the 12x squared minus 4x minus 5. So you can see where I'm going with this, hopefully. Here they had a y in common. Here they had something in parentheses, but it was the same in common. Let's look back here. And of course, after that, we would continue, in both of those cases, we would continue to try to factor the 12x squared minus 4x minus 5. We'd ask ourselves how many terms, be 3, and then we'd go on from there to convert to 4 and try to factor. Okay. So what are we looking at here? Well, notice we have the 12x squared times something in parentheses, minus 4x times something in parentheses, minus 5 times something in parentheses, and all three of them are exactly the same, x minus 1. So that is our GCF. So being boringly good here, is there a GCF? Yes, and it's x minus 1. We pull that out, and what's left behind is our 12x squared minus 4x minus 5. We pulled out the x minus 1, and there's our trinomial that we now have to factor. Continuing to be boringly good, the next thing we ask is how many terms are left over. And we're looking at 1, 2, 3. The 12x squared minus 4x minus 5 is a trinomial. So now our options are to trial and error, trying to fit those into factors by splitting up the 12, splitting up the 5, and adjusting the signs until it works. Or we can convert those three terms to 4 and factor by grouping. Or we could see if it's a perfect square trinomial using our 7.4 leftovers technique of seeing if the first one's a perfect square, third one's. If you've memorized that, it doesn't take long to check for it. 12 is not a perfect square, neither is 5, so that's not even an issue. We're going to go with the method we've been working on the notes, and we're going to convert 3 to 4 terms so that we can factor by grouping. So convert to 4 terms so that we can factor by grouping. So we start by identifying our A, B, and C values. Oh, and just as a reminder, let's take that GCF that we pulled out and bring it all the way down to our final answer so we don't forget about it. A equals 12, B equals negative 4, C equals 5, and we're going to note that it's negative because that's going to tell us to subtract. And now we're going to take our A value times our C value. In this case, 12 times 5, that gives us 60. And we're going to split that into factors and find the pair of factors that multiply to give us 60, but will subtract to give us negative 4. So 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10. As soon as you find the pair, you can stop listing, because there will only be one pair if it's factorable. In this case, 6 and 10 is the pair we want, because 6 minus 10 will give us that -4 that we're aiming for. That equals our b value. So what that means is now we're going to take that 6 and -10, and we're going to make the -4x, we're going to split it into 6x minus 10x. That's equal to -4x, but it gives us that strategic split, which will then allow us to have 4 terms, and we can factor by grouping. So we're going to rewrite this as 12x squared, the original 12x squared, but we're going to split the -4x into 6x minus 10x. And notice I did a positive 6 because we have positive 6 minus 10 equals -4. And then we bring down our -5 from the original. We're now at 4 terms. We can factor by grouping. What do the first two have in common? They have 6x in common, leaving behind 2x plus 1. What do the next two have in common? They have a 5 in common, and the first term sign being negative clues me in, tips me off, reminds me that I need to pull a negative GCF out, so a -5, leaving behind a positive 2x plus 1. And we can expect these to match. That's a good way to catch yourself. If they don't match, you've done some sort of error, or you forgot to pull a negative. So then you've got a big GCF here of 2x plus 1, and what that leaves behind is our 6x minus 5. And good thing we wrote down that GCF as a reminder at the end here. Our final version is x minus 1, the GCF we pulled out originally, and then the two factors of the 12x squared minus 4x minus 5, 2x plus 1, 6x minus 5. I'm going to go ahead and adjust the camera now, because we've just got a little bit left on this page, so we'll do it all in one video. On page 447 of the book is a helpful reminder for our strategy for factoring polynomials. They mention the GCF, then the number of terms. They've got your special formulas here if it's 2 terms. They've got your perfect square trinomial if it's 3 terms. This one is really optional because all trinomials are factorable either by the trial and error or grouping. And we've done the grouping part in the notes. The book focuses a little bit on trial and error, but either way is fine. The box method that you may have heard about or know about is a visual version of factoring by grouping. And if there are 4 more terms, we factor by grouping. So they walk through this whole strategy here. And then you check to see if any of the factors can go further. This is a piece that we're just now starting to emphasize because you might be able to take it further. Check to see if you can keep factoring it. Okay, I like to call them layers, and I'm highlighting this because there will be at least one on the test where you can keep going on the factoring. A difference of squares might show up or something like that. Okay, and you can always check by multiplying it back out. We could refoil and redistribute and get back to our original here. And then as you finish the assignment, there'll be some application exercises. These are word problems, story problems, or some related to real-life data problems. Because we're in the section on factoring, you can expect that no matter what they're talking about, part of the solving of it will involve factoring. So you can expect to factor on these. And then, of course, you'll finish up with some review and some preview exercises. And that will take you through 7.5.